Welcome to my knife destruction video. The star of this video is the knife you see before you. It's a field knife by Nathan Carothers of Carothers Performance Knives. Nathan has been making the field knife for some time now and has made previous versions in a few different steels. This particular knife is made with his latest and greatest, a steel that he calls Delta CPM 3V, or just Delta 3V. As I understand it, he has developed a proprietary heat treat that takes CPM 3V to the next level in performance. In other words, this knife should outperform a similar knife in CPM 3V that has undergone a more typical heat treat. As you can see by Nathan's writing on the blade, this knife has an edge bevel of 20 degrees per side, is 0.026 inches thick behind the edge, and is hardened to 61.5 on the Rockwell scale. So this will be a destruction test. That means that we are going to find out what it takes to break the tip, roll or chip out the edge, blow through the secondary bevel and get into the primary grind, and ultimately bend, or better yet, break the knife into at least two separate pieces. And depending on how things hold up as we progress, I may test the scales too, since I've not really seen any destruction tests of micarta scales, which is what these scales are and which are standard option on Carothers Performance knives. I'm going to say this again because it is important. This is a destruction test. It says so on the side of the blade, break me. That means that most of what you are about to see is not normal use of a knife. In other words, please do not try this stuff yourself, and don't try to talk your friends into it either, as funny as you think that may be. Seriously, use some common sense, folks. Any attempt to recreate things done here is at your own risk. If you don't want to risk injury and bear full responsibility for any injury or property damage you may cause, just don't attempt anything here in this video. It's that simple. If you still need convincing, think about it like this. When you break your nice knife by using it in some way similar to how I use this knife in this video, don't blame me or Carothers Performance Knives that your knife may not be covered under warranty. Enough said about that. Finally, in this video, there will be no comparison of the field knife to any other knife, custom or production, nor will I compare Nathan Carothers or Carothers Performance Knives to any other custom maker or manufacturer. This test is solely about this knife and what it can stand up to, or not. Alright, all that said, it's time for the good stuff, so sit back and relax. With any luck, this video will be both entertaining and educational. So one of the things that I like a knife to be able to do is strike a spark on a ferro rod. A lot of times when I'm camping or out hiking, if I need to start a fire, that actually is my preferred method of starting a fire. So I've got a ferro rod here. What a lot of people use is something like what I've got here, which is a part of a hacksaw blade. And you can see the ferro rod works. So what I'm going to do is grab the knife here, and typically people will use the spine of the knife on the ferro rod because they don't want to damage the edge. Now on the field knife here, the spine is not rounded, but it's not exactly square to the side of the knife either. It's sort of a softened corner, if you will. When I try to get some sparks from a ferro rod with the spine of the knife, it does not work. There's some jimping up by the thumb. That also does not seem to work. You've got the pommel of the knife where it is shaped basically to act as perhaps a glass breaker or a pry. That can generate some sparks. It's hard to, because it's so narrow, it's actually somewhat hard to drive it down the length of the ferro rod without it slipping off. But you can generate some sparks that way. Essentially, with a knife and a ferro rod, the only other way that I'm aware of that you can really start a spark is by using the edge of the knife. And so what I'm going to try to do is use the back edge of the knife, and you'll see where I'm going with this here. But I want to see if it, I have no idea, I want to see if it is going to create some sparks here. And it does. It actually does it very well. Doesn't appear to be any appreciable degradation where I was doing it. Might seem to have roughed it up a little bit. But what I'm interested in is, will the back edge of the knife where I did the ferro rod, is it able to push cut paper? So I've got a piece of printer paper here, fairly thick, fairly good quality, and in the middle of the edge, if I push cut, we have a clean cut. Now that I've used a ferro rod on the very back portion of the knife, I'm interested to know if the edge has been degraded enough that it can no longer push cut. And it appears as though that may be the case. Can't really seem to get it started here. A little bit. Yeah, it's definitely not impossible to cut through the paper at that location. It's definitely harder than the rest of the blade. Just so everybody knows, the blade is very sharp. You know, cutting this paper with a draw cut is easy. So you might not want to necessarily use the blade edge itself on a ferro rod, but if necessary in an emergency, or you've basically run out of other options, you can use say the back ½ inch of the edge without an issue. I would imagine you could probably use it for a long time in striking sparks off a ferro rod, and the rest of the knife would still be as sharp as it was before you started that process. So what I've got here is some kind of compressed wood chip type board, and what I'm going to be doing is driving the tip of the knife into it and then attempting to pry the tip out using this board as the media. Here is the tip of the knife before I have started. Now let's see what, if anything, the board will do to it. All right. Not going to kill myself on it. I think I'd probably have to go through lots of these boards in order to make a difference. The tip is still very sharp and looks pristine, looks unaffected. Next up, I've got this 2x6. This is an old piece of wood that's been sitting outside, very hard as a result of it. I'm in Arizona, there's a lot of dry heat here, and I think in the past couple of years it being outside, though protected from rain, it's probably a bit weathered and again very hard. I'm going to be batoning the knife tip into the wood this time, try to get a little bit deeper penetration and see what happens. I'm not certain if you can see how much the tip is going into the wood here. It's actually going in okay, it's about that far. You can see what's being pried out of it. There is something where you can see the thickness of what's coming out of it. Okay, let's take a look at the tip. Again, still very sharp with my thumb, at least as far as my thumb's concerned. I'm gonna try this in the light, see if you can see it a little bit more. I don't know if that's better, but to my eye, tip looks completely undamaged. Here we have a eucalyptus log. It's been sitting outside in the Arizona heat for some period of time, a couple of years at least. Very hard, very heavy, and we're going to do some more batoning into the end grain of the wood at first and see what, if anything, we can do with breaking the tip or bending it or degrading the tip on this knife. that one may have gone in a bit too far, that I feel like I could pry it out safely. Okay, let's take a look at the tip of this blade. Still very pointy, very sharp. Still appears to be no edge degradation at all on this. Well, we're going to try the side of the log next. I want to show you the top of the wood where I've been batoning first. Get a close-up on that. Here's the top of the eucalyptus log that I've just batoned into. Some of those are pretty deep. Certainly could have broken the tip. At least I think it could have broken the tip, or would have expected it might break the tip, but tip looks good so far. Now let's try longitudinally into this log and see if we have a different result. Okay, I've got a different eucalyptus log here. The other one wanted to roll a bit when I laid it on its side, and I didn't feel it was perhaps the most stable platform to be batoning into. So I've got this one here. It is actually from the same tree and was cut at the same time. I would expect roughly the same hardness, and we're going to try batoning the knife this way and again see what the tip can take. Yeah, I can tell already that this is literally no challenge at all. For this knife. We might have a little curvature in the tip of the blade at this point. Not sure if anybody can see that, but we do have some curvature, but still very sharp no breakage of the tip, and it seems like very little to no degradation of the edge. I am going to say that from about here forward, there's a little bit of curvature in the blade, and you can see sometimes going into the wood that it's been pounded in and pried from a depth of maybe a ½ an inch from the tip. I'm going to try prying in the opposite direction with the tip and see what impact that has on the tip. I'm not sure, but to my eye it looks like maybe, if anything, it may have straightened it out just a bit, prying it in the opposite direction from the way that it was bent before. Still, no damage to the tip, which it hasn't broken. I guess I would have expected that it might break at the very tip, if even only the blade was pounded in a ½ inch or more. I think the stress is at the very tip, which is a little bit thinner, would have caused it to break. But no such luck yet. We'll keep trying though. All right, there we have it. The tip finally broke. So what it took was repeated pounding and prying into the eucalyptus wood. Again, it's very hard. The tip started to bend one way, then I tried to get it bent back the other way. I think I pretty much straightened it out, and then I started prying and bending again in the way that I was going originally, the direction I was going originally, and what we have is a failure of the tip at this point. So we're going to do some stuff with the edge and see what it takes to degrade the edge. You can see it's broken back a little bit from the tip. Up to that point, in looking at the tip, there did not seem to be any apparent change or deformity in the tip structure itself, other than, again, it seemed to be ever so slightly bent to one side. But the very tip could have easily gone into my hand. If I had tried to stab my hand, it could have easily penetrated flesh and a number of other things, and of course continued to penetrate the eucalyptus with the baton. But there we have it. The tip on the knife is broken from some significant lateral stresses due to batoning in the wood and prying. This is obviously a 4x4 block of wood. We're going to play with the edge on the knife a little bit now, do some batoning with it, and see how the edge holds up to going through this wood. As you could see, not much of a challenge for the knife at all. The edge has no deformation whatsoever, no rolling, nothing. And I'm going to just see if we can still draw cut paper. Doesn't look like the edge has been affected much, if at all, by the simple task of batoning through that 4x4. We're going to try a couple other things here. Stand by and we'll get back. Next up is a piece of mesquite wood, seasoned mesquite wood. You can see that it's got some knots in it, pretty gnarly. I think mesquite's pretty hard generally. We'll see what it does for this knife and whether this knife can get through it. You can see that I've gone through a couple of the eyes on the mesquite. So there is the wood, and here is the edge after batoning through the mesquite wood, through a couple of different knots in the wood, the eyes. You can see the markers wearing off quite a bit, but to my finger and thumb, the edge still feels pretty sharp. I'm going to get a piece of paper and we're going to see if I can still draw cut the paper. The same paper, of course, that we started out with. when we started this test, the same exact paper. Clean cuts. Appears to be literally, to the naked eye, no edge degradation. The edge is also very smooth to my fingernail, suggesting that there are so far no rolls, chips, nothing like that at this point yet. Okay, I have just pulled out an antler main beam from an elk and the knife from a deep freeze where it's been sitting for about the last 24 hours. It's literally been out of the freezer for about 1 minute here, and I'm going to try to baton the knife through the antler crossways and see if the edge will hold up. A lot of vibration coming through the knife, hitting it with this 11-pound sledge. Well, it broke the antler trying to baton through it. I'm going to try to baton through the rest of this little piece that remains in an effort to accurately get an idea of what going through the whole antler is going to do to the edge. Well, there you have it. There you have it. There is the antler. Almost looks like somebody took a saw to it and then broke off the remaining part of it as I got near the end. And the blade, here is the edge of the blade. Try to get that to focus on the edge. Feels a little rough. Not quite as sharp as it was before, but no discernible chips. Might be some ever slight rolling. I don't know if I'm getting it on video very well. Kind of in the middle of my middle finger there, right about there. Looks to be some slight rolling, but yeah, right there. I would say that is barely there. Barely there. It might look larger than it really is. Okay, well, here is the other piece of the antler. As it got down into the center, I guess that's when the antler decided to fracture. But all in all, the knife made it through. I don't think using this knife in the field to clean an animal is going to pose any issue whatsoever. If you come up against bone or even want to split a pelvic bone or the sternum of an animal with this knife, normally something I would use a hatchet for, but I don't think there's going to be a problem with this knife. On to something tougher at this point, I guess, as the knife is still intact. One thing I forgot I want to point out before we move on to a different media to try to put the knife through is the antler. Again, you can see it's fairly big, but just as an objective measure, I've got a tape around it, and the circumference is about 5 1/4 inches. It is a big antler for sure. So 5 1/4 inches is what it chopped through. It fragmented some of the external part, but made it through all fine, really. No issues whatsoever. For my next little trick, I've got this car tire, this automotive tire, picked up from the back of a tire store. They were discarding it There doesn't seem to be any visible damage to the tire. It just looks like the tread's worn down, and whoever had it on their car prior to my getting it was simply changing out the tire because the tread was low. There's no damage to the sidewalls whatsoever. So I'm going to try to cut through this with the knife. It indicates on the back of it that there are several plies, 2 polyester, 2 steel, and 1 nylon. So I've never seen this done before. I don't know if the knife is actually going to be able to cut through it or not, especially after I've beaten up on it a bit, but I'm going to give it a whirl and see what happens here. Trying to cut through the same spot here, and I'm not making much progress. Well, for what it's worth, I'm not making any progress through the tire at the wall here, beginning of the wall. I will say this, I think I'm obviously running up against some steel in there. This feels right here from really about there to about there, this length, this portion. It's almost like a butter knife now. So not something the edge is going to hold up to, and at this point it's not something that I'm going to try to cut through because it's clearly dulling the edge already, and I still have a few things that I want to do with this knife besides sit here for God knows how long trying to cut through a tire with a steel belt in it and an edge that's pretty dull. So, okay, well, the tire, it did not cut through the tire, probably why I didn't see that in any other test anywhere, but I'm going to try to baton it through a variety of different media and see what the edge can handle and what the tip can handle as well. I'm going to, here's a picture of the tip before, and I think what I'm going to do, if I have the tools, I'm going to take the spine down and make the tip pointed again. Try to keep it cool, try to take it slow, and that way at least I have a usable tip again that comes to a pretty fine point, much like the original, even if the top geometry is a little different. But it should be a good indicator, I think, whether the tip can go through things like concrete and other media like that without fracturing. Of course, this fractured in trying to pry it through some very dense wood, and that's fine, but I'm very curious to see if you can take it and pound it through concrete type media, bricks, cinder blocks, things like that. Okay, on to the next test. Okay, the next test is going to be a test of whether the edge can get through this. This is 1,400-pound galvanized cable. It's about a 1/4 inch thick. There we go, 1/4 inch thick. And I've got a little vise here in front. We're going to see if we can't pound the knife through the cable on top of the vise. I've got a bit of the cable marked off as well as a bit of the knife marked off. What I'm trying to do is use the same edge at the same spot on the cable to get through the cable and provide some consistency. The cable is cut in half quite cleanly. And the edge looks unimpacted. No rolls, no chips. Next up is this. It's a flat washer. I don't know how big the hole is in the center, but it is just shy of 0.15 inches thick. Looks like about, I'll take that back, 0.10 inches thick. And we're going to put it in my vise here. I've got some support on the front of the vise since it's not bolted down to anything at the moment, but I've got some support on there so that when I hit it there will not be any movement of the vise. Here's the knife. We're going to use the same edge portion again in this test. Let me make sure this is tight enough. And actually, as I look at the knife, got a chip out of the edge already. It's the right portion, the right half there. You can see where it's chipped out of the edge. So that's what it takes to get through the primary grind. I might return to this at some point, but I want to try a few other tests as well, just to make sure that the edge can withstand those. So I've taken the tape off the knife. I'm going to show you so you can see it a little better. There is the chip taken out of the edge. There is no metal on either side. Definitely a chip, not a roll. Not something that you couldn't ultimately fix, although you'd be taking away a lot of metal to get there. And I want to show the tip as well, because I'm actually going to not modify the tip at all. I'm just going to try to pound it through some cinder blocks and bricks and such using this tip as it is. We'll see how much it changes. And this is the piece of steel that I was trying to pound through. You can maybe see at the top there, it didn't get through it very much at all. It knocked it to the side a little bit. I don't know what kind of steel it is, but something that they would use for a washer. So we might return to this, but right now we're going to go to trying to smash the point through some concrete type media. Something else I want to point out on this vise where I was pounding through, I was using this area to pound through that cable a minute ago. You can see how the knife bit into that flat top portion of the vise. I don't know if it's hardened steel or softer steel. I can tell you that plate area, that flat area, was pretty much pristine before my little attempt at cutting through that cable. And there was no chipping from the edge at all in that area as well. It looks to be about maybe 1.5 inches to 2 inches long right here, and no chipping or rolling of the knife edge in that area at all. Nothing discernible. Alright, on to something else. Got an old brick here. The top surface to the top of that hole is about 1.6 inches thick, and this is going to be a test to see if the tip of the blade can get through that brick without breaking more than it already has in its current condition. Looks pretty much the same to me. Okay, here's a piece of cinder block. The top surface to the top of that hole is about 1.35 inches thick. I don't know if this media is harder than the brick or softer or equivalent, but I'm going to attempt to do the same thing with this and see where we go with the tip. All right. Honestly, it doesn't look like it was a challenge at all for the tip. Okay, let's take a close look at the edge, because next I'm going to do an edge test on a cinder block to see if it'll get through it. Alright, on to the next test. Okay, this is a 2-inch thick piece of the same material that cinder blocks are made out of, whatever you want to call it. It's concrete, I guess. And I've got it resting on 2 boards, so it is slightly above the ground that it's resting on. What I don't want to do is try to transfer the impact of the hits to my porch. So I've got it up on the wood, and hopefully that will help to isolate the impact to the block itself rather than the underlying cement. This is going to be a test of the edge, since we just saw the edge, and we're going to see if there's going to be any difference in the edge once we get through this block here. Turns out, unbeknownst to me, there was some wire holding this brick or this block together, reinforcing it. You can see it here, 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 and here. So when it appeared as though I chopped through this, it wasn't coming apart quite yet because that wire was still holding it together. And here is the edge after going through all of that. It's definitely getting a little more banged up, but still it's not something that honestly, a good sharpening job would take care of it. You'd be removing a bit of metal, but it could be done, and you'd still have a workable knife. I'm hitting the top of this, the spine, with the sledgehammer, and there's just a bunch of gunk from the tape that was up there before. But hitting it with that sledgehammer, it appears to be basically unfazed or unchanged by that as well. I'm also hitting it back here on the pommel area, and you can see it goes to almost an edge there, but that edge is not chipped out or degraded in any way. Okay, on to something else. What I have here is a piece of ceramic tile. It's going to be 0.30 inches thick. It's not a big piece at all. I'm going to try to pound the edge through it, and we'll see if the edge can withstand it. As anybody knows, ceramic tile is extraordinarily hard. I have no belief that the knife is going to cut through this. I think it's going to break through it, and question is, will the edge be affected more than the tile itself, which hopefully is going to get broken here. Well, that was easy. Here's the edge. Still kicking. I'm going to take you around the edges of the knife as it exists at the current time with no modification, no sharpening, simply what it looks like from a close-up perspective based on what we've done so far. This is the left side of the blade. Now the right side. Back to the left side now. Okay, so we've just taken a look at the edge, and what I have decided to do is to sharpen it up a little bit, clean up the blade, sharpen the edge a little bit. The only thing that I've done to it was essentially use this little contraption. It's a Spyderco Sharp Maker. It is at the 20 degree per side, 40 degree inclusive setting. And what you see are the triangle rods used as an angle guide and rest for this Dia-Sharp diamond stone. The stone is 2 inches wide, and I have only touched up the knife using the coarse side and the fine side of this Dia-Sharp. I've also used a steel on the edge just a little bit, but this has been the predominant tool that I've used to sharpen the edge. I'm mentioning this because I'm going to show you something in a second that I think is relevant to what's going on with the knife. It's just my theory, but you can think about it and agree or disagree as you choose. So let's go and take a look at the knife edge as it's been sharpened up on this sharp maker, and I want to point something out and we'll go from there. Okay, so here is the edge of the blade after I've used the sharp maker. This is the right side of the edge. What I want to point out is the waviness in the top of the bevel as it approaches, or as it gets into the primary grind. You can see it right there to the right of that chip, that waviness. And the waviness continues a little bit farther down the line, essentially to the back of the blade. You might be able to see it a little better on this side as well. This is the right side of the blade now. You can see that extreme waviness right there. At first, when I saw this, I wasn't really sure what to make of it. But then I thought about it a little bit. It's very pronounced there. I thought about it a little bit, and what I decided was that what I think is happening is that the edge is rippling left and right of the basically left and right of the spine, the longitudinal spine. And so with that 2-inch stone, what's happening is as metal is pushed to one side of the blade, the stone is essentially sharpening the edge on the opposite side in a higher or lower level on the primary grind. I also wanted to point out that it's a 2-inch stone. I've used it many times before. I think I'm fairly adept at using it. I've never seen this before, although I've never done a destruction test before either. But the point is that in the flats of the edge like this, there should be up to 2 inches touching the blade and touching the edge, sharpening it at any one point. Yet we have this waviness there, and the only reason that it can really be explained as far as I know is, again, some metal is touching the stone while other metal is not, sort of along the same plane. And the only reason that would be is because there's a slight rippling of the edge. It's just my theory. It seems pretty common sense to me that that's what's going on, but others may choose to disagree. I don't have any kind of a device to measure how straight the edge is relative to the spine. I don't have any kind of scientific instrument like that, but I think with the light we can see that there are some changes in the edge along the primary grind. So here you can see to the right of the chip, the primary grind goes down closer to the very edge apex, And here, what was the right of the chip on the other side is now the left of the chip on this side, and you can see that the sharpener was touching the metal farther away from the apex than on the other side. So a rippling in the edge left and right of the center line of the spine is my theory. Enough about that. Back to some more testing. By the way, this edge is fully capable now of draw cutting that paper that I initially used when I was testing the edge on this to begin with. I'm not going to do it. Just take my word on it. I tried it. It will pull cut, draw cut, and it does so until it gets to this chip, and then it hangs up. But it's a pretty smooth cut, and even these little microchips in the back don't seem to really be a big deal at all. They could probably be sharpened out. They could be sharpened out if I continue to sharp and take away more metal, but honestly, I don't see what the point of that would be at this point. So on to some more testing. Here's the next setup. Basically, the knife is wedged in between a couple of boards with some elevation, and I'm going to stand on it and see how much it flexes or if it breaks. There is about 2 inches, 2¼ inches of the knife sandwiched in there to the broken tip, and a little over 2 inches out the back to the handle. So, standing on it, even though I've got a little bit of foundation extending out over the point that holds the knife, I was finding that it was wanting to potentially roll on me. So I've made a little modification here. Hopefully that should do the trick. Let's see what it'll do. All right, let's try take 3. So I've got a builder square here, just kind of looking to see how much the knife has bent after our last test. I'd like to think that these things are square, but maybe not. So I'm using the same portion of the square and just doing it from different sides of the knife. It looks pretty straight to me. I don't really see any difference between one side versus the other. And there's no discernible difference just eyeballing it either. Still very straight. I think that most watchers of this video probably know that Nathan does quite a bit of testing himself, and he's got a couple of videos out there that he has done where he tests the edge of different models of the knives that he makes. One of the things that he does is he takes a hammer and pounds it through I forget, it's something like a 10-penny nail or a 16-penny nail, basically a big old nail, and shows that there is little to no edge damage. Actually no edge damage. There's no little about it. There's nothing there. I'm going to do the same thing, but I'm kind of the opinion if you're going to do it big. Do it really big. So we've got Mr. 11-pound sledgehammer. We've got the knife. You can see the point of impact is going to be between the two pieces of tape, a bit far back from where that initial chip in the blade was. I want to get into some area that might be a little bit stronger in the blade, not compromised at a molecular level. Or at least not likely or as likely to be compromised. And then the nail is going to be this nail. If you can call it a nail. It's actually a spike. You can see it's going to be about 0.375 inches thick, and just so everybody knows, I don't know what steel this is made of, but just so everybody knows, it is galvanized. Like I said, Nathan, if you're going to do it big, and I think this will hopefully be big enough. We'll see. All right, let's take a look at the nail first. Nice and shiny. No chipping or breaking there. All the way through. Now for the edge. I'm going to move it here. Let's try to get out in the light. I think there's an ever so slight roll right there. Keep in mind, this is the sharpened edge. As it came to me originally with 20 degrees per side, sharpen it up a little bit, enough to draw a cut through that paper that you see at the beginning of the video. And so we're dealing with pretty much a fresh edge, much closer to the original than the one that we were dealing with after beating the blade up before. And there is a very, very slight roll. Very slight. Basically, it didn't do anything to the knife. I'm sure folks remember the washer. You can see there's a little bit of nick in that left edge that I tried to baton the knife through this and caused a chip in the edge. So we're going to repeat that now that I've touched up the edge. We're going to repeat it with a different part of the edge and see if we're going to have any better luck this time. You can see the part in between the two tape strips here is where I'm going to try to use the edge at that location to try to get through that washer. And you can see after 2 hits on that washer, we've got another chip in the edge. Not sure what's with that washer. It's been tougher than anything we've tried to go through so far. So at this point, I'm going to say that the washer wins, and I'm going to stop, at least at this point temporarily, stop trying to pound the edge through it, and I think we'll play with the point some more. This is a close-up of the washer. You can see that the knife didn't get much farther this time than it did the first time. This must be some sort of hardened steel of some type. I'm really surprised it would do that to the knife. Okay, onward and upward. As everybody can see, the knife now has a new tip on it. I put a new tip on it because I wanted to test the tip to see how strong it was by putting it through another test or so. In order to approximate the strength and thickness of the tip as it originally was, I simply took the spine down to the edge where the tip broke off. So the edge isn't really lifted any higher. We're not getting into the thicker metal in the upper part of the knife nearer to the spine. And it's not a perfect edge by any stretch. There may be a roll or a very slight chip in it still, but without getting that out, the edge is 20 degrees per side, at least according to the sharp maker. And I'm guessing that the tip is about the same strength as the original tip that was on here. So we're going to put the knife through at least one more test and see if the tip will hold up. My next test is going to involve pounding the tip of the knife through this, hopefully several times. It's a long piece of steel flat. With my calipers I've measured it. It is 0.10 inches thick, and we're going to see how many times the tip will stand up to being pounded through this. Here's how the tip is holding up so far. Looks pretty much unscathed. Wish I could say the same for the butt of the knife. going to take a break and we'll get back to the drawing board. Finally starting to get a little bit of blunting at the edge, or at the tip rather. Let's keep going. The tip continues to blunt ever so slightly. This is supposed to be a knife destruction test. I'm wondering if the knife is going to win or if I'm going to win at this point. Well, I think I'm going to stop, if only to catch my breath. I am literally trying to drive an 11-pound sledgehammer through the knife. I'm lifting it up and I'm hammering down on it very hard. So it's more than 11 pounds hitting this blade for sure. And frankly, I'm just getting worn out. Here is the tip as it stands. You can see that it is blunted. It could still penetrate things, but it's not especially pointy to the touch. If anybody cares, I pounded the knife through the steel total of 24 times, all tipped down, getting beat on by that sledgehammer, and the tip is suffering only minimal damage. I mentioned it before, and now that I'm going to stop, I'm going to show it again, which is the butt end of the knife. Try to get this camera to focus. There we go. You can see how much the sledgehammer has affected the butt end of the knife. Actually seems like the sledgehammer hitting it has affected it more than the tip was affected by going through the steel. Alright, one last shot of the tip. We're going to try something else with this tip. Okay, we've got a cinder block type brick in front of the camera, and we're going to see how many times the tip is going to be able to handle going into this. Well, made short work of the brick. As far as the tip goes, it's a little more blunted, but really negligible. Very little change. I don't know if it'll make a difference, but we're going to try breaking this. Larger brick here. Different material, of course, but it's also about 3.75 inches thick. A little more than twice as thick as that last one we pounded through.
And there's the tip. Again, I think it was, I think it's a little more blunt now than it was before I started on that red brick. But I think the difference is, again, very small. For anybody contemplating taking the handles off of the field knife in order to put their own handles on, or perhaps a cord wrap of some type, this is what the handle underneath the micarta slabs looks like. Only that hole in the very back is visible. Everything else is covered by the micarta. Took the handles off because I'm going to test the micarta here in a couple of silly ways, but two, this knife is about ready for the break test, and I want to be able to get something attached to this handle that's going to give me some leverage. Two, it gives everybody a chance to see what's underneath the handle. So here is a handle off the field knife, the test knife in this particular instance. It's 0.3 inches thick at its thickest, 0.19 at its thinnest. Thickest is going to be right about here, essentially over the center hole. The thinnest is going to be at the back, right over the back hole. Again, 0.19, 0.30 right there. We're going to see what it takes to abrade, I guess, the scale and possibly break it with a quick immediate impact. See if I can't break it, and if so, where it's going to break. Well, that's impressive if you ask me. Didn't break the scale, and just kind of discolored it. A little abraded on the top, but for hitting it with that 11-pound sledgehammer with a backing that's not going to move, it did better than I thought it would. Now I'm going to see if the sledgehammer can break it in half when it's not supported from behind, and the sledgehammer comes down on the center of it. Yeah, the quick impact was enough to do it. Broke the scale essentially at just in front of its thinnest point. Just out of curiosity, I'm going to see if it'll break at the thickest point as well, or break somewhere else if we try it again. It did obviously break. Have a secondary crack right here. And of course it did break at the thickest point as well. But that was again a very hard impact with the 11-pound sledgehammer, driven down with force and no supporting background on the point of impact. Thus, I think basically flexing it to the point where it just snapped. Okay, this is the tip as it stands right now, and I'm going to drop this Carothers field knife tip down into the concrete floor from a height of about 7 feet, and I'm going to just repeatedly just let it drop and see if the tip will be able to withstand it. Well, after one drop, you can see how that's going to turn out. Apparently the tip of the knife is going to chip away the concrete. So rather than deal with that, let's see if it'll chip away a part of a ceramic tile. Save the concrete and don't spare the tile, something like that. Okay, tip is still intact, tile is not. I think that's 10. Tip still looks pretty good. There it is after another 10 drops. Definitely getting blunter slowly. think that is 30 or thereabouts. And there we are at 40 drops, again from about 7 feet. It's a consistent height each time. Try a couple of more. See if it just continues to blunt or if the tip will actually break. Alright, quite blunted, but still no breakage. Pressing pretty heavily, it doesn't really hurt. It's not so blunted though that it couldn't be sharpened out if you were willing to take away a little metal. Still get it back to a point.
Okay, I have put the knife in a vise and we're going to attempt to break it. I think we can do this. You can see how the setup is. Okay folks, here we go. I'm surprised it didn't bend a little bit more than that. Don't mind the grease. Let's see if I can get this to focus here. Looks like a fairly clean break. Okay, and you can see it did not break. It actually broke about halfway in between chip number 1 in the edge and chip number 2. I don't know. Like I said, I think I was expecting it to bend a little bit more than that. It may be that all of my beating on it, especially with that sledgehammer, impacted its ability to bend. There may have been some sort of stress fractures inside. I don't know. I'll leave that up to the scientists to figure out, or the knife makers that are really into this stuff. Of course, Nathan being one of them. All right, well, there you have that. We're not done yet with this steel. One test remaining on the steel, and I'm going to do something with the micarta handle here momentarily to see how strong that is, besides the sledgehammer test. Okay, I've got this contraption set up. Let's take a closer look at exactly what I'm doing here. We'll call this a MacGyver scale. So I've got a heavy piece of wood down there on which I'm going to lay some weights. I've got a couple of 1,500-pound tie-down straps. And then up here, I have got the scale hanging from a single strap. I've got the screwdrivers there to keep the side straps supporting the base from slipping off. And you can all see that that is the scale. I don't want it to move to one side or the other, so I'm showing you the scale now, but I'm going to cross wrap it with some packing tape in an attempt to keep that scale centered. Then I'm going to start slowly adding weight to the base, and we're going to see how much this micarta scale can handle in terms of weight before it breaks. Alright, I now have tape in place on the scale. I wanted to show it to you beforehand, just not that there's going to be any question, but clearly it is the other scale from the knife. All right, let's start out with, let's try 30 pounds. That would be a no. Doesn't even look like the scale's really even flexing. 60-pound dumbbell. Not really seeing a lot of flex there. £125. Still not a lot of flex. As I think about it, I'm expecting that this is going to be an immediate break as opposed to a lot of flex. $185. There we are. Sorry about the crappy videography here, folks. So I attempted to put another 25-pound plate on top to bring it to 210 pounds. And the scale broke, or the scale broke pretty much square. The strap itself is 1 inch wide, and so you had what did I say, 210 pounds on the center of the strap, with the pressure approximately 1.5 to 2 inches on either side, pulling pretty much equally. All right, here is a close-up look at exactly where the scales, or the scale, broke. Almost a perfect fit there. As you look at it from the side, it did not break at the thinner area over here or here, but rather square in the center at the thickest part, but where the hole is. Almost right through the center of the hole. Looks a little jagged on this side, but if you look at the back side of it, it's a break that is just about as straight as a ruler. So there you have it. That takes care of the second scale. One test remaining. Don't know how long that's going to take. Basically, I'm going to put the steel in water and see how long it takes to rust. Alright, here we've got the field knife. It's been sitting in water for somewhere between 50 and 60 hours at this point. You can see where it's beginning to rust. Primarily, of course, around the areas where the steel is not polished. So where it was broken,
or on the butt of the knife or the spine of the knife where it was pounded on pretty good. I'm going to see if this rust is actually just kind of on there permanently at this point. Does look like there is some pitting in some of the areas. A lot of it is just on the surface, but some of it definitely feels like it's down into the steel. Again, that's after about 55 hours sitting in this water. Have a pretty good pit right up here on the spine. Again, a lot of it's surface rust that could probably be worked on, but I don't think this is a knife that you want to leave outside, especially in a high humidity environment or the rain for any period of time. Alright, with that, that will conclude the Carothers field knife destruction test. I hope that it's been somewhat informative and at least tolerable to view. If nothing else, hopefully it will provoke a little discussion on how certain aspects can be improved or what is good enough. Thanks for watching, and we'll catch you next time.